Hi everyone, welcome back. In this video, I am going to show you how you can evaluate a scikit-learn model, for example, support vector machines, using KFold cross-validation. And I seriously hope you watched my previous video where I talked about what cross-validation is and what KFold is, and provided a bit of a context that really helps you understanding this video and the upcoming videos. So if you haven't watched that, I definitely recommend you doing that first and then coming back. And also for the future videos, please hit the subscribe button so you get notified when they come out. And if you're feeling extra generous, try to find the thanks button right next to the subscribe button and be generous. Okay, let's jump into today's topic, which is, like I mentioned, evaluating a scikit-learn model. Now, if you are lazy and do not want to watch my previous video, okay, I still recommend doing that, but here is a quick context, quick background. So what you need to know is that KFold is a model validation technique. You have a model, you want to know how good is that model for a given problem. So you can validate that model for that specific problem using KFold cross-validation. It is not a technique that will give you a good model. It's not a technique where you can train a model and then get a good model that you can take and use in production for future use. It's just an evaluation. You can use it to kind of find the right parameters and model and then retrain that later on, but that's the intention of KFold cross-validation, is not to provide you with a stable model that you can use in future. And cross-validation between multiple folds allows us to evaluate the model performance. So you divide the data into multiple folds. That's what KFold library does. It provides you the test train indices for your data, so you can divide them into different folds. So if you have 500 data points, if you have 500 data points and your k equals to 10, then each fold will have 50 data points, and of those 50 you would be using one of the folds for testing and the remaining for training purposes. So one group is used for testing and the other one is used for training purposes. And also by default it's consecutive folds. So if you have 500 data points, it's like first 50 and then the next 50 and then the next 50. But you can actually tell the code that you interact with to shuffle the data, in which case obviously the data gets shuffled before the data gets split. And all combinations will be used for cross validation. And in this specific video, we will be, of course, working with Python, scikit-learn. We will split the data into multiple folds, and we'll do two things. First, we'll iterate through each fold manually, train and validation. Why? Because that's a good way of understanding exactly how things work in the background. But if you are after one value, which is cross-validation score, which is what just show me how the model is performing, one metric, the mean cross-validation score, then there is a shortcut right there. Yeah, there is a method, built-in method that's called cross-val score that can be used, and we will actually look at that. And how do we do this? So I will be using support vector machine, and the data set that we are going to use is the Wisconsin breast cancer example. I've used this many times in the past. If you do not know, a quick summary is you have, I believe, about 30 attributes, which is what is the mean radius of the tumor, I guess, and the texture of this tumor, and so on. So you have 30 such features, and then one column that actually shows you what the label is. Is it malignant or benign? So that's the data set right there, and it's available. Again, I'll share the link as part of the description, so you can download it if you want. It's just a CSV file. Okay, I think we are all set with that information. Let's go ahead and jump into the code. And I do have 3 files right here. I'll share all of those. Again, look for the link under the description down below. And the 3 files, the first one is just a quick introduction to understanding the data set. But more importantly, okay, if you do not have KFold cross-validation, how would you typically approach this problem? And I did this in the past, but I wanted to quickly repeat this so you know that, hey, this is the normal way of doing it. But then with KFold cross-validation, this is how we enumerate it through each of the folds using for loop. And finally, hey, shortcut. Yeah, if you are looking for shortcut way, just go all the way to the end of this video, although you may find some little nuggets of information when you watch these videos. Maybe a new way to display data, I don't know, but try to watch the entire videos, and also try to watch the advertisements because it provides money that I want to donate to charities. Okay, guys, with that, let's go ahead and jump in. And here is the information. So let's go ahead and import sys so I can print out exactly what my Python version is. It is 3.7.11. And I'm using scikit-learn. We are going to use scikit-learn, and the version here is 101. Let's go ahead and import pandas because we need to capture this table that I showed you, the CSV file, as a pandas data frame. And I am going to also import seaborn or pyplot. It's up to you, so we can quickly understand how the data looks like. Okay, now is the time to read the CSV file and store it as part of a data frame. So let's go ahead and do that. And when I open the data frame, you should see that I have a whole bunch of columns right there. I believe about 31, because one of those is diagnosis right here, benign or malignant. So this is our label. I don't like the title diagnosis for multiple reasons, because one reason is it's hard for me to say it. So I'm going to replace that with a label called label. Easy, right? And what other attributes do we have? Radius, texture, and so on. Yeah, so there's a whole bunch of attributes. Again, look at the documentation for this data set to understand what it really means. But let's understand the numbers first. So let's describe the data set. We should have, 31 rows, 8 columns right there, and we have 569 data sets. And these are all the 569 data points, and these are all the attributes: radius, texture, perimeter, area. Some of these are related, right? Obviously, these are not independent parameters, like perimeter and area are probably, and the radius are probably related unless they're measured in a different way, but I can't understand why that would be. But anyway, so there is concavity and all of these other parameters. So how can we fit that to a support vector machines model? But first thing first, are there any null data points, right? So we need to take care of those. We do not have any, so not much to do. Otherwise, I usually drop any null rows or fill it with some values, but yeah, it's up to you. Okay, now I already mentioned I would love to rename diagnosis to label. Let's do that. And now let's finally look at the data types, and everything is a floating point value except for a label, which is an object. Of course, our label is M or B, so it's a text. It's not a floating point, it's not a number, and our ID is an integer. Okay, and let's understand the data point. How many malignants versus how many benigns do we have? So let's go ahead and print that out. We have 357 benign, 212 malignant. So it's not really that balanced. If you want to balance it, you can go ahead and do that. I mean, the same information, if you want to plot it visually, you can understand how it looks like. There you go. So more B compared to M. And you can watch one of my previous videos where I talked about data imbalance and how to balance it, what type of different techniques do we have. Again, that's a different discussion, so I don't want to get into that. But if you want to do that, this is the time to do all of that. Okay, now let's define our X and Y values for our machine learning. So Y is very simple. It's nothing but the label right there. So that column, so that is my Y. So let's go ahead and extract that. And if you open this, our Y, you can see it's that single column that we extracted. So now this is an array object. Now let's go ahead and define our X. And our X is all the columns except for the two that are not attributes, ID and label, right? Except for these two, all the other columns are our X values. If you want, you can pick and choose which ones you want to use. So let's use the remaining 29 right there. So there you go. Okay, so now that we have our X and Y ready, typically what do? We use our scikit-learn model selection train test split, and we split our data into, in this case, I'm using, let's do this. In this case, I'm using 25%, holding 25% of my data as for testing, and the remaining 75% for training. So this is how we typically do. Let's go ahead and do that. In fact, let me also mention one thing. I used to do this bad habit. I used to have this bad habit of normalizing or scaling the data. Talk about little nuggets of information when you watch the video. If typically I used to at least normalize my values right there, or scale the values if you want to call it, like for example min-max scaler or standard scaler, etc., right there, and then split the data. Never ever do that. Never do that, because always first thing, remember to scale and normalize after splitting. Because what happens when you do your scaling or normalizing? Well, you are for example, if your X data has data that goes from 0 to 100, and when you normalize the entire data, it's like normalized to 100, right? So that's the maximum if you're doing min-max scalar. But when you split it, what if your X train has only the highest value to be around 75, but then X test actually has the values up to 100? Then your data mean and the standard deviation is different between these two. So when you normalize and provide that information during the training process, when you normalize ahead of time, then the training already knows what the spread looks like in your test data. So some information from test is leaked into your training, which is not ideal, right? So that's why you need to, I think there's a term called, it's basically the information is leaking into the training process, and I added the notes right there. So that's exactly why you need to be scaling them after the split. So we did split here. So we have our X train, X test, Y train, and Y test. And why you're not doing anything, I mean, you can convert them into integer encoded, because right now we have M and B. You can convert them into integer encoded or one hot encoded if you're doing neural networks. But in this case, we do not need that. Support vector machines and random forest, they can handle these type of textural labels. So let's leave it as is. But our X values, we are going to scale them. And I'm choosing to use min-max scaler in this case. Again, available as part of scikit-learn. The way you do that is you define your scalar object and you fit it onto the data, and then you kind of scale and transform your test data or whatever the future data is. So let's go ahead and run these lines, and now our data is all ready. Okay, so our X right there, X test, as you can see, the values are now 0.2 instead of, we should have looked at the numbers before I said instead of, but I have no clue what it was. Anyway, now let's go down to, this is how we used to fit, right? I mean, you have your support vector machine, SVM, and svm.svc or kernel. We are going to use a linear kernel. You can use cross-validation here. I mean, I'm going to use cross-validation, not cross-validation, sorry, our C value right there equals to 1. There is no cross-validation within this SVC. We'll do that in a few minutes. And you set your random state, and let's go ahead and run this, and you fit your model, and you predict your model, and you print out your accuracy, right? So this is how we do it, and I got 99.3, great. But what if I shuffle the data? What if this gets split in a different way? For example, if I split this, I don't know, 10, yeah? So let's go ahead and run all of these, and how does the accuracy look like? Now I got 99.3. What did we get? 99. Is it doing anything? Let's do this in a nice methodical way. There you go. There you go. And model.fit. I was expecting different values, but 99.3, what the? That's a surprise. 1, 20, 42, probably 10 split it in a way that's very similar to the previous one. I was testing these, so let's go back to these and check this one more time. Hopefully we'll see a different value, otherwise I have no clue what's going on. Okay, that was a weird coincidence. The way my random state equals to 42 and random state equals to 10 was splitting the data in a very similar way, so I got the similar accuracy. Now I split it in a different way. I got 97.2 instead of 99 point something. I also tried what 20, right? So let's try this one more time before jumping on moving further. So there you go. And what did we get? 96.5. So as you can see, as you change how the data gets split, your accuracy is changing. And KFold is just a methodical way for us to actually split the data in a structured way, not a random way. This is the random way, right, that we tried, and then evaluating the model. That's exactly what we are going to do here. So let me clear everything right there and start from scratch. I'm not going to explain everything all the way down to where we have our x right there. So far what we have is just define our x and y. That's it. And from this point on, how do we do our KFold validation? First thing first, again, we need to perform here. I did not do any min-max scalar because previously we did the split. We did the split right there, and we are scaling the values. But right now we are not doing the split. We are letting the KFold do the split. So we have to do the scaling after the fact, after the split happens. Yeah. So just a quick note. That's why I only have x and y. That's it. Now I want to import the min-max scalar library. I want to import my support vector machines. In addition to that, I want to include import my KFold. It's available as part of sklearn model selection. So there you go. And I am creating my KFold object right there. So SKF is KFold. How many splits do we want to split this data into? So let's select a number of splits equal to 7. It's customary to use 10 or 5, sometimes in between 5 and 10. So let's just do 7 splits in this case, and random state, whatever the random state you want to keep. 42 is the ultimate answer to the ultimate question of life. So that's why I have 42 right there. And I'm going to leave shuffle equals to true. I want to shuffle the data and then do the splits. Okay, so let us go ahead and run this line, and now you can see the SKF is the object, KFold object. Now we need to use that object. How do we do that? So first thing first, our X is a data frame right there. So that doesn't work. In our case, we need to convert that into a NumPy. And you know how to do that. X array, X to NumPy. So let's go ahead and do that. And why didn't I convert that in the previous case right here? Again, these are basics of Python. I didn't do that because when you apply min-max scalar, it automatically converts that into a NumPy array. That's why I didn't do that. Now I have to do it deliberately. That's why I'm trying to change that to NumPy. And now if you look up here, now we have an array of 30, 569 by 30. Okay, so now let's go ahead and create a split object. So our SKF object right there, KFold dot split with this input data. So when I do this, you should see my splits object being generated. And again, I encourage you to understand exactly what that split object does. That's exactly what these 3 lines are. So this is a split object that walks you through individual folds. So if I just do my next, walk through these individual folds and look at the split object and go ahead and print out. Let's go ahead and do that. Right there. I'm printing only the first 10, not all the 82 right there. Oh, by the way, we split this into 7 groups, right? Number of splits, and we have 569 data points. So 569 by 7 is 82, and you have 82 groups. The data gets divided into 82 groups, and we'll see that in a second once we get down here. But of those, I'm just of the first split, I'm just looking at the first 10 data points, and you can see the train indices are 0, 1, 3, 4, 5, 6, 7, 8, 9. So 2 is missing there, 6 is missing, 10 is missing because they are available as part of test. Yeah. So that's the indices right there. And why is it not continuous 0 to 50 and then so on? That's because we put shuffle equals to true. I hope that makes sense. Okay, so now let's create a couple of empty lists because we want to capture the predicted and expected. Yeah, so we can do the accuracy for each fold. So I created an empty list right there. We also define our scalar as min-max scalar, and we'll be scaling inside the loop once the split happens. And how does the split happen? So for train index and test index, remember the split is going to give us the indices. The split is giving us the indices right there, 0th, first, second, third, right? So we go through each of those indices and then we get our X array, and we get our for our train and test, and we also get exactly the same for our Y values, the and then we are going to do our fit right here for train and test. We are going to transform them. We are going to apply the min-max scalar, and then we are going to do a training on this data. First we define a classifier, and then we fit right on our X train and Y train. And this X train and Y train, it changes for each loop right here. So it's manually enumerating through each group of these 83 groups that we just create by doing this split. Okay, and of course, once the model is trained, then we need to predict. And how do you do? Classifier.predict on your test data set. So that's the predicted for this fold. For this fold, that's the predicted. And I want to capture that as part of our empty list right there. And I would also capture the expected value, which is nothing but our Y test values. And of course, I'm also calculating the accuracy, which is metrics.accuracy score between your test and the prediction. And I'm going to print that out. Okay, so let's do all of that. It should be pretty fast. It shouldn't take that long. Let's go ahead and run it. So there you go. So apparently my first fold, the accuracy is 1. The second, 100%. Second fold, 98.8, 94, 93, 97, 97, 95, 98. There you go. And if you want, you can actually average all of those. Let's see, what am I doing here? Oh, I'm just printing the accuracy right there. Sorry, not average, but accuracy score, expected, predicted right there. And when you do that, it's giving me 97.363. What am I? Sorry, I should have been prepared. Oh, from all folds. Yeah. So this is the accuracy from all folds. There you go. We are getting 97 point whatever that value is. So this tells me how well my support vector machines is working with a C value equals to 1 and random state equals to 42. But random state, you can change it. But this tells me how the model is working on this data set. Now, we enumerated all of this, but it's very easy. Again, let me end the video by showing you how easy it is to just use a built-in method. So let's clear everything here. And again, I'll do exactly the same I've done before. Run these lines all the way to right here. Yeah, remember we converted our X to our array, NumPy array. Now what? So how do we do this right away? So the trick lies here, cross-val score as part of scikit-learn model selection. So let's go ahead and run all of these. And now prepare the cross-validation procedure. So how do you prepare the cross-validation? Again, exactly same as before. Number of split 7, random state, shuffle equals to true. Let's go ahead and do that. And what is our model? Our model is support vector machine with these parameters. Go ahead and do that. And now I am defining my scalar and then scale the values. But this is the wrong way. You know that. I already mentioned about it. You do not want to scale the values before and then print it out. But if you do that, again, we cannot tell that it's wrong just by looking at this. If you do that, the way you do apply your cross-validation score is you provide a model. Which model do you want to use? We want to use this one. And you provide your X values and you provide your Y. And what is your metric that you want to report? Scoring. In my case, I want that to be accuracy. And what cross-validation process do you want to use as part of your cross-validation score? We already defined this up here. We want to use this. And number of jobs equals to -1. It parallelizes the calculation right there. So that is it. This is how you use it. And scores, it takes a while. It needs to go through all of that. And now let's go ahead and print the accuracy for each fold. And it's very similar to what we got before, right? 100%, 98, 93, and so on. But again, like I said, this is not the right way to do it. The right way to do it is by actually scaling it inside here, inside your cross-validation. And how do you do that? And let me end the video by showing you the right way to doing it. So let's import all of these libraries again. And the key one here is the pipeline. Scikit-learn.pipeline, import pipeline. Yeah. And again, let's convert our x, let's get our x array again, and let's define our model equals to support vector machines. We know this is exactly what we did before. The key difference now, what we're trying to do here is instead of just providing my model and x and y and all of these, I'm going to create something called a pipeline. And the pipeline is created. First, let's give a variable steps equal to a list. I'm just creating a list. Yeah, a list of what? A list of my scalar, what scalar to use, and what model to use. And then I create a pipeline. So if I run these, the steps is nothing but a list right there showing us this is a tuple of size 2, scalar, min-max scalar, model, support vector machine. And if you want more, you can go ahead and add more. And I'm going to create my pipeline with these steps. Okay, I created a pipeline. Rest of the story is the same. I create my setting for cross-validation, and let's go ahead and do the scores again. I gave it new value so we can compare with the other one, but here instead of the model, I gave it pipeline. And then this is the input X, this is the input Y. And as part of the pipeline, it takes care of this, this part of the min-max scalar part. So let's run this and print out the scores right here, and also print out the scores from before. Yeah, just so we can compare them. There. So this is the wrong way of doing it. This is the right way of doing it. I mean, in this specific example, they look almost identical, but it's again, it may be different, for different types of data. In fact, am I doing the same? Oh, sorry. They look almost identical because I'm printing score, not scores 2. Sorry about that. No. Yeah, I should have changed the parameter right there. That's okay. Let's go ahead and look at this, and mean accuracy of overall is that. Yeah, so this is the mean accuracy that we are actually getting from this process. Okay, so what did you learn? You learned how do KFold in general, what it looks like as part of our manual enumeration. But then if this is the right way of doing it. Yeah, so you define a pipeline, and as part of the pipeline is how you want to scale it, what type of model do you want to use, and all that stuff. So define your pipeline, and for your cross-val score, provide the pipeline as input, your x, y values, and how you want to score it, and what the cross-validation technique is, and that's it. A single line does the entire job for you. Okay, I hope you learned something new here, and in the next video, let's actually take this concept and then let's try to tune some hyperparameters as part of this machine learning model. So if you want to get notified, please hit the subscribe button.